Hey guys, welcome to Conceptual Geometry, Lesson 6.4, Square Proofs. Properties of a square. We're going to start by listing the 5 properties of all parallelograms. I'm sure you guys know these by now. Opposite sides are parallel. Opposite sides are equal. Opposite angles are equal. The adjacent or consecutive angles are supplementary, which means they add to 180. And the diagonals bisect each other. So if I just stop there and use those 5 properties, basically I've proven a parallelogram. So those are our parallelogram properties. But a square obviously has additional properties. So what else do we know about a square? It has 4 equal sides. Well, so does a rhombus. So what makes this a square? In addition to 4 equal sides, it has 4 right angles. And what about the diagonals? They're special also. The diagonals are equal and perpendicular. So basically a square combines all the properties of a rhombus and of a rectangle. Now, how are we going to prove that a shape is a square and not just a rectangle or a rhombus or a parallelogram? What we are going to do is we are going to use these 2 properties. 4 equal sides and diagonals are equal. All right, so using those 2 will prove a shape is a square. So how are we going to do it? Use 6 distances to prove 4 equal sides and equal diagonals. So it's very similar to what we did for a rectangle. This is actually going to be easier because all 4 sides are going to be equal. You don't have to match up opposite sides, and the diagonals are going to be equal. All right, prove ABCD is a square like we've been doing all unit long. You guys may use the coordinates and the specific distance formula, square root x2 minus x1 squared plus y2 minus y1 squared, or you can be visual. I'm more of a visual person. You guys know that by now. So I'm going to use the diagram and basically use my Pythagorean theorem. Doesn't matter what side we start with. I'll start with DC. So the distance from D to C equals the square root. And again, this is work you need to show over here. I know I've mentioned this a lot throughout the unit, but we have to show that for using this visual method. So delta x is 2 by counting there. Delta y, 1, 2, 3 is 4. So I have 2 squared plus 4 squared. You can throw that into the calculator, or this is pretty easy to do. 4 plus 16, that's square root 20. Now I know because it's a square, all 4 sides better be square root 20. But you have to show that because this is a proof. So next I'll do CB. Okay, so CB, count these. Delta x is 4, delta y is 2. Those numbers are the same. It does not matter what order you put those in. You'll still get square root 20. Okay, next, the distance from B to A. So I'll do this, show the work. Again, we get 2 and 4, so that's 2 squared plus 4 squared, either order, square root 20. And finally, the last side is going to be AD. So let's see this, just confirm. Yep, that's 2 and that's 4. Square root 20. So now, what does this tell us? All right, we have to make a conclusion about our results here. And we know that DC equals CB equals BA equals AD. So if I just stop here, I've proven it's a rhombus. 4 equal sides. I could stop here and say it's a rhombus. Unfortunately, it doesn't say prove it's a rhombus. It says prove it's a square. So now what we need to do is we need to find the length of the diagonals. So one diagonal will be CA. And this is where it gets a little bit more challenging because it really helps if you have a straight edge. What you want to do is connect CA. And then we have to make a triangle using that as our side. So it's a little bit easier here because I've got this bright color. But that's the triangle I would make. So my delta x is 2. My delta y is 1, 2, 3, 4, 5, 6. So this diagonal will be 2 squared plus 6 squared. 2 squared is 4, 6 squared is 36, so that gives me square root 40. And lastly, I have to find the diagonal DB. Well, I'll use a different color again, just so you can see where I'm getting these numbers from. And this is where it gets a little bit more challenging, like I said. And some of you might prefer to use the distance formula here, but it's not necessary. So there's the right triangle I'm using for that diagonal. Delta x, 1, 2, 3, 4, 5 is 6, and delta y is 2. So you can see the numbers are the same here. That's another reason that this is a little bit easier than rectangles, because the numbers for the diagonals will always be the same. In a rectangle, they weren't. The end result was the same, but the numbers under the radical, the delta x and delta y, were different. Okay, so what I know here is that CA equals DB. So all that's left to do is to write our conclusion. A, B, C, D is a square because it has 4 equal sides and equal diagonals. Okay, quite a bit of work. All right, this and rectangle I think are the two most challenging. This one may be slightly easier than rectangle. Let's do one more. Example 2, prove ABCD is a square. They give us the coordinates, they give us a picture, your choice which one you want to use. I'm going to use the picture. So we'll start by finding the length of the 4 sides, distance from A to B. Okay, so I'm going to make a right triangle there and count my delta x and delta y. Delta x, 1, 2, 3, 4, 5. I have to write that down. Delta y, 1, 2, 3, 4, 5, 6, 7. So I've got 5 squared plus 7 squared. Now again, what I would expect you guys to do is put this into the calculator. 5 squared is 25, 7 squared is 49. So if I add those together, I believe that gives me 74. So square root 74 is that length. Next, let's do distance from B to C. I know the numbers should be the same, but we have to write it down. We have to show it. So this time delta x is 1, 2, 3, 4, 5, 6, 7, and delta y is 1, 2, 3, 4, 5. So 7 squared plus 5 squared. Again, it doesn't matter what order you put those in. That gives me square root 74. Distance from C to D. Okay, let's keep going. Delta x is 5, delta y is 7. So again, same two numbers. And the distance from A to D. One more. Delta x is 7, delta y is 5. Confirm that. 7 squared plus 5 squared, square root 74. Now let's make a conclusion. Look what you've shown using the distance formula. AB equals BC equals CD equals AD. Okay, so all 4 of those sides are equal. Now we need to do the diagonals. I'll pick diagonal AC first. So using a straight edge, connect those and make your triangle. It's a little bit harder to see, especially if you're using pencil and paper because you have one color. So there's the triangle, delta x. Let me count across here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is 12, and delta y is 2. So the distance from A to C would be square root 12 squared plus 2 squared. So 12 squared is 144, 2 squared is 4. Add those together, you get square root 148. Okay, now I'll find the distance from B to D, the other diagonal. So let me connect those 2 points and make this triangle. Delta x is 2. Let's count delta y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the same. That's good. 2 squared plus 12 squared again equals square root 148. So I know AC equals BD. So what have we just shown? The 4 sides are equal, which makes it a rhombus, but then the diagonals are equal, which then makes it a square. All right, so I have to mention both of those things when I write my conclusion. A, B, C, D is a square because it has 4 equal sides and equal diagonals. All right, so that concludes day 4. As usual, guys, if you have any questions, don't hesitate to reach out and ask. Thanks for watching, and we'll see you in class soon.